So in the previous video what we did was selection sort. Okay, so in this video we'll do a new sorting algorithm to this bubble sort. Okay, let's see what we need to do inside of that. It's simple. Okay, again it's simple. If you see properly, it's simple. Okay, so let's understand this. Let's see. I've been given something like, let's say 3 4 1, let's say 2. Okay, in bubble sort what we do is, let's suppose round 1. Okay, I will be like, I'll compare these two values. Okay, I'll compare these two values. Hey, what is kept at 0 index and 1 index? Okay, hey, is this greater? Now see, is this greater than this? No. Okay, great. First you were here. Okay, first you were here and you were comparing this value with this value. Okay, next you went to this part. You're like, hey, is this value greater than this? Yes. Swap them. In case it is greater, swap them. Okay, afterwards you were here and now you came out here. You came out here, that means now you compared, hey, is 4 greater than 2? Yes, it is. Swap this 2 also. So 4 will come here and 2 will come here. So after round 1, what can I expect? If you see properly, this is something that I'm expecting. What are the advantages? Let's see. Firstly, what can you firstly tell me, did your array code sort it? No. But what can you say? Your last, who was the greatest element is at the perfect position, right? Also, if you see properly, since the size of array was 4, okay, how much value I needed to travel? I needed to go till here only, till n minus 1, right? As soon as, see, n minus 1 means I was actually at index 2. Okay, at index 2, because indexes start from 0. So as soon as I was at index 2, that means as soon as I was at n minus 1, okay, n minus 1, that means I had okay, we will do that in that part in code. Okay, actually we need to travel till index 2 only. Right now understand, till index 2. Okay, as soon as it becomes n minus 1, I need to stop. N minus 1 means equal to 3. It means as soon as the value of I or whatsoever will try to denote it, it becomes n minus 1, we need to stop, because we need to go till index 2 only. Why till 2? Because I am trying to actually compare this value with the ahead's value, right? Making sense somehow? So see, in round 1, I went till here, the whole of the array. I traveled to the whole of the array, or you can say till last second array. Okay, last second element. Okay, I should say. I traveled and I found that, hey, this is the greatest. Making sense? Round 2 come here. Round 2. In round 2, what will happen? I'm like, hey, compare this value first with this. See, starting, if you see properly, in round 1 also, start was 0 and was, if you see properly, and was here only. That means index 2 was your end. Index 2 was your end. Here also start is 0. What is the end? I let's compare it. I compare, hey, 1 is greater than 3 is greater than 1. Yes, make 1 here, make 3. Hey, is 3 greater than 2? Yes, make 3 here and make 2 here. Do I need to go further? Do I need to go further? No, because I already know that, see, this will surely be the largest. So like, even if you want to do it, you can do it, but it will be of no use. Okay, so even if you just stop even at index 1 also, then also things will work. Why it will work? Because as soon as I'm at index 1, I'm actually trying to copy like compare this value and I plus 1. If this is I, then I'm actually comparing I value and I plus 1's value, right? If it's greater, swap it. If, see, if greater, swap. Okay, if greater, swap. Makes sense? So if you see properly, in my round 2, I need to go from 0 to 1 only, right? 0 to 1 only. After this, things would have taken place. I will somehow get my arrays, right? I will be here, and now like, hey, I'll be going till from 0 to 0. Okay, at least I'll go one time. Okay, because I will compare. Hey, is this value greater than this? No, not greater. Then I'll be like, hey, if not greater, then just remain as it is. That means I can, after my round 3, I can assume, or basically, yeah, round 3, because this was round 2, right? So this is round 3. We'll do one more example. Okay, don't worry. After this one, I can assume that this is actually sorted somehow. Let's take one more example. Perfect example. In order to make you guys explain properly, I'll take a good example. Okay, let's take something like, okay, let's take values. It's still 5 values. Okay, 5 values. 5, 3, 2, 8. Let's take this. Okay, now come. Round 1. What did I say? Start from 0. Okay, and travel full. Okay, you need travel full, but how? First compare this with this. Hey, is this 5 greater than 3? Yes, greater. Then at that time only just swap it. Make sense? Now you'll be like, hey, is this greater? Is this greater? Yes, swap it. Then 2 will be here and 5 will be here. Right now, what values I've got? 3, 5, and sorry, 3, 2, and 5. Okay, come here. Hey, is 5 greater than 8? No. Then still remain as it is only. Okay, after that, you'll be at this position. Hey, is 8 greater than 1? Yes. Swap them. So 1 will come here and 8 will go here. After this, I told you, you need to go till here only. Why? Because when you are at this position, you are trying to compare the last value also. So it doesn't make sense to go here. If you go here, then you'll compare with what? You'll compare with this value which is out of your array, right? So you need to go and stop here only. Make sense? Okay, after your round 1, you got this value. Is this array sorted? Obviously no, but you are sure that, hey, this part got sorted. That means whatever 8 was, 8 is actually at its right position right now. Okay, next comment. Next again, you start with from round 2 also. Start with 0 only. Okay, hey, is 2 greater than 3? Oh, sorry, 3 greater than 2? Yes. Swap them. You were at this position in the beginning, okay, and swapped it. Next you come to this position, and now you're like, hey, is 3 greater than 5? No, not greater. Then you're like, okay, let's move to ahead. Hey, is 5 greater than 1? Yes. Then you're like, hey, since it is like this, let me actually keep 1 here and 5 here. Make sense? As soon as you're here, if you want, you can compare it. Okay, let's compare it as of now. Okay, compare 5 with 8. Is it greater? No, then just keep it, but you need not compare it. Okay, because you already know that this is the greatest. Then if you know that it's already stronger, then why do you need to even compare it, right? But if you want, you can compare it. We'll just see. Okay, we'll see from the both approach. Okay, we'll compare it, and also we'll try to actually optimize our code. Okay, that means without comparing it. Right now, let's do it comparing way only, so it makes more easy for you. It's more easier for you. Okay, so after reaching here, I'm going to compare 5 and 8. 5 will be on in its place only, because it will not get swapped. Okay, round 2 over, come to round 3. Hey, round 3, you will be having something like this: 2, 3, 1, 5, and 8. If you see properly, hey, is 2 greater than 3? No. Oh, great. Hey, is 3 greater than 1? Yes. Make 1 here, make 3 here. Okay, you are at this position. You don't have to compare it from this. Okay, but still, if you want to compare, you're like, okay, I'm here. Hey, is 3 greater than 5? No, obviously no. You'll like, again, you'll come here and you're like, hey, 5 is greater than 8? Obviously no. Then you need not compare. I'm just saying. Okay, but if you want to compare, you can compare. It's just waste of time, but I should just, okay, but for beginning purpose, you can just compare it. Okay, see, after round 3, you'll get something like this. After round 4, what can you expect? Hey, is 2 greater than 1? Yes, swap them. 1 will be here and 2 will be here. Hey, is 2 greater than 3? No. Is 3 greater than 5? No. Is 5 greater than 8? No. It means after round 5, round 4, you can actually somehow say that you will be getting these values. Round 4, element 5. If you see properly, we have gone till only 4 rounds. Okay, starting from round 1. Okay, starting from 1 I went till 4, so I went from 1, 2, 3 and 4. If you see properly, if you consider from I, then if you start from 0, then you need to go from 0, 1, 2, 3 only. Okay, if that means if there are 5 elements, then you need to go till index 3 only. Okay, we'll see this part in code also. Okay, but somehow I hope the idea is clear what we're supposed to do. In every round, just see who is greater and swap them. If in case you're finding that that's greater, just swap it. Okay, so let's see in code. It'll make more sense to us. Okay, when we code it, let's just code it. Just code it as stream using namespace std int main. So let's copy this part, which is not that hard for, like, which is somehow similar. So we'll get an array. Okay, and this part is gonna be same, except that this is not gonna be selection sort. Right, we'll get an array. We will try to get the value of n. We will try to actually keep all the values. Afterwards, we will print the values. But before printing, we need to perform something. That is not selection sort, but this is gonna be bubble sort. Okay, so let's rename it bubble sort. But obviously, we will be giving the array and the size of the array, right? So let's go and implement the bubble sort. Obviously, even this will return as null, void, right? Because everything, all the changes will take place in the array itself, right? So it's gonna get an array, this right array, and with the n value. Come here. Let's right now focus on the only one round. Okay, so if I say properly, I equal to going from 0 to I less than n minus 1, right? N minus 1 means if in case value of shoot you second, just give me a second. Let's say 3 7 1 2 9. Let's see. Okay, so I need to go till this part only, right? This is equal to 0 1 2 3. Index 3, index is 3, values, number of elements n equal to 5, right? That means I need to go till 3 only. Okay, that means n minus 1, as soon as it becomes 4, just stop. Okay, because I need to go till index 3, right? And starting index is 0. Make sense? So this is basically your for round 1. Okay, here, and let's see here, and what are we supposed to do here? Let's see. I'm coming here, I'm like, hey, if ARR of I is actually greater than ARR of I plus 1. Okay, that means if what is kept at index 0 is greater than index 1, just swap it. How do we swap it? I think now by now you guys already know it. ARR of I, store that value inside your temp. Okay, now rewrite the value of ARR of I. ARR of I, rewrite the value of ARR of I plus 1, right? And now ARR of I plus 1 will be written by temp. Make sense? Let's see what I am saying. Let's see what I'm saying. I'm saying this. Let's say it's not like this. It's actually like this. Okay, 7 is here and 3 is here. Let's suppose. Okay, I'm like, hey, is it greater? Yes, 7 is greater than 3. Okay, great. Inside my temp store 7. So temp will consist of 7. Okay, ARR of I. Now make ARR of I with value ARR of I plus 1. So okay, make this here 3. Okay, now ARR of I plus 1. What is the value? Whatever is in temp. So what is in temp? 7 is in temp. Come and update the value 7. Make sense? This was for I equal to 0. Okay, next time I will be equal to 1. So next time this will be swapped, this will be compared with this. In case it is greater, then it will be swapped, and then so on. And then so it will be swapped like this. 1 will be here and 7 will be here. Next time I will be 2. So 2 value and this will be considered this value. Okay, index 2 and index 3. I'm like, hey, this is actually greater. So okay, let's just swap them. Okay, as soon as I reach here, it means I equal to 3. I'm like, hey, is I equal to n minus 1? So I equal to 3. Okay, is it less than n minus 1? N minus 1 is 4. Here it is less than 4. Then do the checking. So hey, is 7 greater than 9? No, not greater. So obviously whatever is being kept, it is actually in its own right position. Okay, so If you after this 9 will be stored on the right position, right? I can assume that right 9 will be on the right position. Again come again go from 0 only. Okay, again go from 0 only in the next round also, from 0 to 1 to again just compare the whole of the area. Okay, I need to do this till how many times? Till how many times? See, first of all, I need to do this. Let me show you where I have written this. I went till round 4. I went till round 4, right? Just a second. I'll explain to you here. Okay, yeah, see here. Just a second. I'll take an example and I'll explain to you, okay? And you guys are going to guess how many rounds we need to actually consider, okay? Let me take a perfect example for that. Let's say 1, 7, 3, 9, 2, okay? See here, in the first round, okay, r equal to 1, okay? I'll go and actually I'll compare all the values. I'll be like, hey, 1 is correct. This 3 will be here, 7 will be here, okay? And this 2 will come here and 9 will come here. Round 1, after round 1, this is perfectly fine, right? After round 2, I can compare, hey, this is greater, no, this is greater, no, is this greater, yes, then 2 will come here and 7 will come here. After round 2, this 2 will be perfectly fine, r equal to 3. R equal to 3, again I'll compare, hey, is 1 greater than 3, no, is 3 greater than 2, yes, swap them, right? After round 3, this 3 will be perfectly fine. After round 4, I'm like, hey, is 1 greater than 2, no, then obviously after round 4 I can be sure that this part is already sorted. After round 4 I am sure that this part is already sorted. But if you see properly, if this part is sorted, this whole part, then obviously even this will be sorted only because this is the smallest. So I went how many times? 0, 1, 2, 3. I went, if in case I'm going to consider from 0 to I'm going to go till here, till 3. 3 means what is the value of n? N equal to 5. So I'm going to go till as soon as it becomes n minus 1, just stop. That means as soon as it becomes 4, okay, until unless it's 3, I am good to go. Okay, as soon as it becomes 4, just stop. So I'm saying that we will need to go till this part. I'll just show it to you. We need to go till here. Okay, where is it? We are doing this for only round 0, right? So let's even do it for round whole round. So let's just take int j equal to 0. I have to go till where? J less than n minus 1, right? And j plus plus. Make sense? Okay, so let's go and let's finish it here. Okay, let's see whether we're getting the answer or not. Okay, and even if you don't go till n minus 1, if you want to compare even the last value, you can do that. Okay, so if you want to go till n also, you can, it's fine only. Okay, make sense? So I'm just trying to optimize it. Okay, I'll optimize one more time. I'll just show you that optimization, but before that, let's first see whether this is working or not. Okay, let's just see what is the error. Expecting an error is, sorry, I'm not plusing the values. I plus plus. Yeah, come here, let's get the values. It's happening and so enter n means let's take 5 values. Okay, the values is 3, 4, 5, 1, 2. Okay, what should I expect? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Make sense? See, even if you do it till n also, it's fine. Okay, even if you do it till n, it's fine. Even if you want to compare the last value, you're like, hey, I don't want to optimize, then it's fine. Doesn't matter. We can actually do this also. Okay, so let's take again 5 and let's take 2, 3, 4, 5, 1. So I'm getting 1, 2, 3, 4, 5. Okay, make sense? Now let's see one thing. Where is it? Where is it? Sure. Let's take for 5 values. Okay, 5 values. Let's just 3, 4, 7, 1, 9. Okay, 0, or let's suppose 9 is here and 1 is here. 0, 1, 2, 3, 4. In the first cell, you're like, hey, see, when I equal to this j equal to 0, okay, I equal to now this part properly. I am gonna go here like, hey, is this greater? No. Is this greater? No. Is this greater? No. Yes, this is greater. So 1 will come here and 9 will come here. Right? Round 1. Okay. After round 1, see properly. In the round 1, I went till n minus 1. Okay. I went till here n minus 1. Right? But in round 2, is it necessary to go till here? In round 2, I'll be like, hey, is 3 greater than 4? No. Is 4 greater than 7? No. Is 7 greater than 1? Yes. Swap it. I was here and I swapped the values, right? But do you think that we need to actually come and check? I need to go here and I need to check the values. Obviously, no. Right? As soon as I'm here, as soon as I'm at this block, okay, and I'm sure that this is already sorted, I can actually try to reduce the count. Okay. As soon as I'm here, then I'll be like, hey, if I'll somehow do here minus j, that means I need to actually go till n minus 1 minus j. What is the value of j? 1. What is the value of n? In this case 5 here. 5 minus 1 minus 1. So he's gonna go till index 5 minus 1 is 4, 3. So it will go till 3, I less than 3. So I need to go till index 2 only. Right, as soon as it becomes 3, it will stop. Okay, so just an optimization, you can do this thing. Okay, why not just let's go till j, till minus j. Think about it, okay? If in case you did not understand, I'm keeping this for you guys again, because okay, let me just cover it. It's fine. Just let me cover it. 0 1 2 3 4. Okay, simply color 3 4, let's say 7 9 1. Okay, see here properly. I equal to 0, that means in the first iteration, sorry, not I equal to 0, j equal to 0, j equal to 0, I'm gonna go till here, right, till here. So the value of j is 0, so n minus 1 j, that means 5 minus 1 minus 0, so it's gonna go 4, it's gonna go till 4. As soon as it becomes 4, it will stop, so I'll go till index 3 only, right? After these values will be something like this. This will be checked, this will be checked, this will be checked, no, this will be checked, and then this will be swapped. So 3 4 7 1 9. Make sense? After round 1, I'll get these values. Okay, round 2, come to round 2. Round 2, I don't want to check this. I know that this is already sorted. So I'm like, hey, okay, no problem. In the round 2, j value will be 1. That means what is the values? 5 minus 1 minus 1. It means I'll go till 3. Okay, that means I'll go, this part is actually denoting till 3. So as soon as it becomes 3, I is becoming actually equal to 3, then it will stop. That means I'll be actually going till I equal to 2 only. So I'll go till I equal to 2. I equal to 2 means index 2. Okay, 0 1 2 3 4. Okay, I'll go till here only. How? Let's see. Hey, is 3 greater than 4? No. But what is the index? 0. Okay, no problem. Come here. What is the index? 1. Hey, then just compare the values. Is 4 greater than 7? No. Come to this index. Index is 2. Okay, I can do because I need to go till 3 only. No worries with it. I can come here. I'll be like, hey, 7 is greater than 1. Yes. Swap it. Okay. I came to this index. I equal to 3. Hey, but this is actually gonna be equal to my this part. So I'll stop. Okay, I'll stop. So as soon as I'm here, I will stop. That means I'll not be comparing these two portion. Okay. Next iteration, when j will become equal to 2. Okay, that means I need to actually compare. See, I'm sure that these two values are actually sorted. So I'll actually try to actually go till here only, because if I'm here, I'll be actually trying to compare this value, right? So let's see. I need to go till index 1 only. 0 1 2 3 4. I need to go to index 1. How will I do this? As soon as the value of j is 2, so 5 minus 1 minus 2, I'll go till index 1 only. If in case the value becomes 2, then stop. Let's see. Hey, is 3 greater than 4? No. Is 4 greater than 1? Yes. Swap them. But right now index value was 1, so I've swapped. As soon as the index value became 2, I'm like, hey, since it became 2, stop. Okay, stop. Okay, so similarly after that, since this already swapped, after that, again j value will become 3. A is 3 less than n. Yes, 3 is less than n minus 1. Even if you want to put, you can put n minus 1. Okay, it doesn't matter. Okay. Yes, it is less. I'm like, okay, if in case it's less, that's great. You go till n minus 1 minus j. N minus 1 minus j means n value is 5 minus 1 minus j is 3. Okay, great. I'll go till 5 minus 4. I'll go till 0 only. I'll go till 0 only. Okay, I'll go till 0 means, hey, is this value 0? Yes. Then compare this value with whatever is this. Yeah, is it actually greater? Yes. So make 1 here and 3 here. As soon as I go next time, j I equal to 1, I'm like, hey, 1 is greater than 0 or something like this. Okay, so stop. Okay, I hope you got the idea, right? What we're supposed to do. This is actually just done for actually making it optimized. Okay, and even same here, if you write here -1, it will actually optimize. Okay, let's do this optimization and then run it and see whether it's working or not. Okay, so let's run it here -1, and here already is j. Okay, just for optimizing it, I'm writing. Okay, so let's just check it and let's give the same values as, let's give 5 values, 1 3 5 2 4. Okay, 1 3 5 2 4 will be converted into 1 2 3 4 5. Okay, even if you want to give some more values, you can just give it, let's say I want to give it 7. Let's give 7. So I want to give 6 5 4 7 8 and 9, and then let's see 1. Okay, so right now this is value, so we are getting it in ascending order. Okay, I hope this program is clear, right? In this program, what we are doing, we're just in every round we're just checking the value, is ARR of I greater than ARR of I plus 1. If in case it's the case, just swap it. Okay, this part. Okay, and this part we're going till n minus 1. Why? Because as soon as I reach the last second element of the array, I know that I'm going to compare the element with last element, right? So I can go till n minus 1 only. Okay, and this value I'm subtracting j because just to optimize it. Okay, I hope this program is clear. Okay, so just go through. Okay, in case if you have any doubts, just ask me. There's no issue with it. Okay, so in the next videos, let's cover some more sorting algorithms. Okay, so see you guys there. Thank you.